Madras School of Physics. Now, as you know, physics is basically a subject in which we normally use logic as well as reasoning. However, the formula to be applied is to be remembered. So our aim is not to drive the formula here. We have to apply the formula to various questions. But before that, you must know the various type of units which we have to use in whole of the electrostatics, the current electricity, the magnetic effects of current, and electromagnetic induction, alternating current, electromagnetic waves. These all topics are mainly related to electricity. And in these topics, we have to use some units, basic formulas, and they have to be applied in the questions. The main aim is not the derivation, but how to apply the formula. That's more important. And wherever it is necessary, we will derive the formula. So, first of all, I will let you know a few units, like the units of charge. You will remember that the units of charge, that is taken as Coulomb. One of the unit of charge is Coulomb. The other charge, other unit, ESU of charge. These are the two main units. And the representation of charge is by symbol Q. Q is the symbol representing the charge. Coulomb is unit of charge. ESU stands for electrostatic unit of charge. This unit is known as CGS unit, whereas Coulomb is known as the MKS unit or the SI unit. MKS stands for meter, kilogram, second, and SI stands for International Standard Unit. Now, these two units can be related, like 1 Coulomb, that is 3 multiplied 10 to the power 9 electrostatic units of charge. Well, you remember, it is necessary to remember that along with ESU, it is necessary to write charge, because ESU also stands for the potential at a point in the electrostatic field, as well as ESU stands for capacitance of a conductor or a capacitor. So you will remember, we have written here ESU of charge. That is, we are relating Coulomb with ESU of charge. 1 Coulomb, 3 into 10 to the power 9 electrostatic units of charge. It will be very frequently used in the applications. Now, if we have to write 1 ESU, like 1 ESU of charge, it can be taken as 1 over 3 into 10 to the power minus 9 coulombs. So we have taken 1 ESU, so this number is put under the denominator, and we got 1 ESU of charge as 1 over 3 into 10 to the power minus 9 coulombs. Now this fractional number can be converted to the nearest whole number. So 1 over 3 can be written as 0.33 and so on, like this. 10 to the power minus 9 coulombs. So it is an unending number. So according to the use of significant digits, we should write this number up to 1 decimal place. So we can write like this. That is, multiply this number by 10, divide this number by 10. So we can write like this, 3.3 multiplied 10 to the power minus 10 Coulomb. So what exactly we have learned here, that is the unit of charge is Coulomb or ESU, one is MTS unit, other is CDS unit, a smaller one. Relation of the two numbers is this one, 1 Coulomb, 3 into 10 to the power 9 electrostatic units of charge, and 1 electrostatic unit of charge is 1 over 3 multiplied 10 to the power minus 9 Coulomb. 1 over 3 can be written as 0.33, that is unending number, multiplied by 10 to the power minus 9. According to the concept of the significant digits, we have to write this number in a proper order. So we multiply this number 0.33 by 10 and we should divide this number by 10. If you multiply this number by 10, it will become 3.33, and if you divide this number by 10, it will become 10 to the power minus 10 Coulomb. So we have reached to a conclusion that 1 ESU of charge is 3.3 into 10 to the power minus 10 Coulomb, and this is the nearest approximation. So we have taken the approximation. That is 1 ESU of charge is 3.3, 10 to the power minus 10 Coulomb. Now, if suppose we have to use nearest approximation, in some of the numericals, we don't use the exact number. So you will remember the order of one electrostatic unit of charge is 10 to the power minus 10 Coulomb. The order of number. For example, if we write 4 into 10 to the power minus 12, the order of number will become 10 to the power minus 12. This is the order of number. So it means that this is the coefficient of this number, and this number, which is in terms of 10, it is the order of this particular number. If you write 5.7 10 to the power minus 11, then order of number will be 10 to the power minus 11. Now suppose that if the number is 55.7 multiplied 10 to the power minus 10. Now this is not the proper way of representing a number. According to significant digits, this decimal must shift towards the left and write the number up to 1 decimal place. So what we will do, you divide this number by 10 like this. We will divide this number by 10 and we will multiply this number by 10. Now 10 means 10 to the power 1. So 55.7 divided by 10. Why we have done it? In order to make it consistent in accordance with the significant digits. Now this can be written as 5.57 multiplied 10 to the power. Add this one to the index, it will be minus 9. So the representation of 55.7 10 to the power minus 10, that will be 5.57 10 to the power minus 9. Now what is the order of the number? The order of the number will be 10 to the power minus 9. If you wanted to make it more accurate or more significant, we are finding that on the second place the number is more than 5. So remove this number and take another number that is here or at this point, say 5.57. So you remove this number 7 and take one more here, and that will be 5.6, 10 to the power minus 9. I hope this type of transformation is clear to you. So here, let us come back to the unit. The order of one ESU of charge is 10 to the power minus 10 Coulomb. So this is what we have discussed about the charge. The second thing which we are going to discuss, that is about potential. So charge, potential, capacitance, these all facts we have to coordinate. We have to combine these facts and we have to use them in numerical problems or the MCQs, that is the multiple choice questions. So whether it is electrostatics or any other branch of physics like alternating current or you can say magnetism, in all these things, these are all the common features. So it is essential to discuss the common features and we have to use them in MCQs and the numerical aptitude. Now our next discussion will be regarding potential. So if we wanted to write potential, it is represented by symbol V. So symbol V stands for potential and its MKS or SI unit, that is taken as volt. So potential represented by V, SI unit, or this is international standard unit, that is taken as volt. But CGS unit, that is taken as stat volt or ESU of potential. Electrostatic unit of potential. Now normally rule is that CGS units are smaller whereas MKS units are bigger. But here in this physical quantity we find that MKS unit, and if we relate it to CGS, in case of potential only, not in other physical quantities. Like in charge, you are finding that for 1 Coulomb, the number is greater in CGS. But in potential, it is an exceptional physical quantity where we find that CGS unit is greater than MKS unit. Normal rule, MKS unit greater than CGS. But in case of potential, exception is there. Exception is CGS unit that is greater than MKS unit. One electrostatic unit of potential is 300 volts and 1 volt is 1 over 300 electrostatic unit of potential. So 1 ESU of potential is 300 volts and 1 volt is 1 by 300 electrostatic unit of potential. So this is regarding potential. Definitions can be elaborately discussed wherever that is necessary. Otherwise, you have already read in the books what is basically potential. Potential is nothing, it is basically the work done to bring unit positive charge from infinity to a point within electric field. So once more I am repeating that potential is the work done to bring unit positive charge from infinity to a point within electric field. Wherever you wanted to ask the questions, please do ask. Like unit positive charge, you must ask me what is unit positive charge. So when we speak unit positive charge, it is 1 Coulomb charge in MKS, or it is 1 electrostatic unit of charge in CGS. So now we have discussed about potential, the symbolization, and this is the relation of the units, and the charge, that is Q, and this is the relation of the two numbers, and we have further converted the number to an order. The order of number will be this particular number. So first of all, make a significant number. We have divided here, we have multiplied here by 10, divided here by 10. So if we multiply, we get this number. If we divide, we get this number. Now this is called a proper number for representing 1 ESU of charge. We have represented it in coulombs. This is an approximation, and this is called the coefficient of this number, and this number is known as, that is the order of 1 ESU of charge, 10 to the power minus 10 Coulomb. MKS greater than CGS, this is the normal rule, but exception is CGS greater than MKS in case of potential. So I hope this is clear to you. And after this, we are going to discuss the formulas for capacitance and the units. Then we will come towards the formula and how we convert one formula into another formula. I hope all these facts are clear to you. Thank you very much, and you will just understand some other videos about Coulomb's law, electrical charge, elementary charge. All these facts we are going to discuss in the next portion. Thank you very much.